Hi everyone, in today's video, let us discuss
objectives. At the end of this video, you will be able to dismantle the motor, read, record, and interpret the winding data for a three-phase squirrel cage induction motor, strip the old winding from the stator, prepare and provide slot insulation, prepare and lay the coils for the distributed type winding, a concentric group of coils. Make end connections and terminate the lead wire. Insulate, bind and shape the overhangs. Assemble the motor. Test the motor for performance. Let us collect the tools and materials required for this exercise. Screwdriver 100, 150 and 200 mm, one number each. DE spanner 5 mm to 30 mm, one set. Ring spanner 5 mm to 30 mm, one set. Cold chisel 25 mm to 200 mm, one number. Ball peen hammer 500 grams, one number. Nylon mallet 75 mm to 100 mm, one number. Pulley puller 200 mm with 3 jaws, one number. Center punch 10 mm to 150 mm, one number. Insulated cutting pliers 200 mm, one number. Side cutter 150 mm, one number. Micrometer outside 0 to 25 mm, one number. Hacksaw frame 300 mm, one number. Steel rule 300 mm, one number. Scissors 200 mm, one number. Soldering iron 125 watt 250 volt, one number. Double-ended electrician knife 100 mm, one number. Multimeter, one number. Megger insulation tester 500 volt, one number. Emitter moving iron type 0 to 10 ampere, one number. Voltmeter moving iron type 0 to 500 volt, one number. Tachometer 0 to 500 to 5000 rpm, one number. Allen key, one set. All of required length and thickness, one number. Spatula, one number. Magnetic compass 15 mm dia, one number. Blow lamp, one number. Electric air blower, one number. Burnt out 3-phase motor with single layer distributed winding of available capacity and double layer, one number. Baking oven with temperature control, one number. Coil winding machine, one number. Burnt out 3-phase motor with single layer concentric half coil winding, one number. Super enameled copper wire as required. Melinex sheet or triplex paper as required. Procedure. Task 1. Dismantling of the motor, recording winding data and stripping the winding. Select a motor having burnt out single layer distributed winding for this exercise. Collect the nameplate details and record in tabulation. Calculate the number of poles from the nameplate details. Enter the number of poles in the tabulation. Alternatively, calculate the poles using the rated rotor speed and round off the value of full number. Remove the shaft key or the grub screw by holding the pulley. Remove the pulley by using a suitable pulley puller. Make a center punch alignment mark on the stator and the end shield cover. To avoid confusion, make a single punch mark on one side and a dual punch mark on the other end of the motor. Remove the grease cup screw. Loosen the bolts gradually, switching from side to side till they are removed. Keep the cold chisel tip between the stator and cover and gently tap the chisel with a hammer and separate the stator and the end shield cover. Pull off the end shield cover and rotor together, parallel to the motor shaft. Hold the shaft in one hand, rotate the end cover and tap it lightly with a nylon mallet to remove it from the rotor. Remove the other end shield cover also by gently priming it out. Inspect the rotor for any defect and the bearing for its condition. If the bearing is worn out, replace it with a new one. All the fastening devices should be kept in a separate tray. Identify whether the winding is a single layer distributed type. In a single layer distributed type winding, the number of coils is equal to half the number of slots and the same size of coils are used throughout the winding. Record the number of coils, number of poles, number of slots, pitch, and record the overhand projection at both ends of the stator in tabulation, and if required, prepare templates by cardboard or similar materials for overhang projection. This will help to check the overhangs after rewinding. Open the end binding of the end and lead connections from the overhang. Trace the group or lead connections and draw the same for reference in your record. The number of coil groups shall be equal to the number of phase into number of poles in the case of whole coil connections, whereas in the case of half coil connections, the number of coil groups shall be equal to the number of phases into pair of poles. Hence, ascertain the group and connection. Remove the wedges. The wedge can be removed by using the power hacksaw blade or shown or by a wedge remover. Cut off the coils in the non-connection end of the stator with a chisel. Pull out the coils with pincers or pliers. In case the varnish on the winding is hard, heat the winding in an oven to about 2000 degrees Celsius for about 1 hour or heat it by a blow lamp. While heating, it is important that the heat should be controlled such that the excess heat will not damage the stampings and the frame or core. In the case of loose coils, cutting of the coils may not be required and it can be removed out through the slots. Record the total weight of the coils, count the number of turns, measure the size of the wire, and record them in tabulation. Some manufacturers may use parallel conductors of the same size or different sizes of wires instead of using a single wire. Take care of this while recording and entering the details in tabulation against wire multiple. Remove all the remaining foreign matter from the slots by scraping with a knife. Clean it by blowing compressed air. Measure the size and shape of the coil. If the full shape of the coil is available, record the details in tabulation. In case the full shape of the coil is not available, prepare a trial coil of single turn and insert it in the slots at the given pitches. Verify the overhang projection, clearance, correct size, etc. Task 2. Prepare and provide slot insulation. Check the slot dimension and core thickness, recorded it in tabulation. Select the slot liner of thickness as in the original. Cut the paper as per slot length or core thickness with an additional length of 10 to 15 mm so as to make the insulation paper to project 5 mm on either side of the slot with cuffed ends. 10 to 15 mm on either side is just an approximate requirement. Large mortars may require a longer length or vice versa. Cuff either end of the slot liner and fold the same to the slot size. Prepare a sample of the slot liner and try inserting it in the slot to see the correctness. Cut and prepare the necessary number of slot liners as per the correct sample. Insert the slot liners in all the slots properly and see that the slot liners project evenly on both sides of the core. The slot liner should properly adhere to the surface of the slots as shown. A wrong method of placing the slot liner. Check the groups or lead connections and also draw the developed diagram of the winding for the given motor. For your guidance, the end connections and the developed diagram are given for a certain motor having a single layer distributed type winding with the following data: 24 slots, 12 coils, 4 poles, 3-phase balanced winding. Task 3. Prepare coil winding and forming. Select a suitable size of former according to the dimension recorded in tabulation. The former is cut with a distinct level edge for two reasons: to permit the coil to slip off the former and to allow a longer peripheral length of the coil at the back. Only one size of former is sufficient for the distributed type of winding. Attach the former securely to the winding stand. Confirm and select the size of winding wire that is given in tabulation. Wind the designated number of turns by leaving 150 mm extension wire. Make sure the number of turns is small as in the original. Tie the coil tightly with twine thread on either side of the coil after winding the coil. Cut the remaining length of wire by leaving 150 mm extension. Remove the coil from the former and check its correctness by inserting in the slots. If the size is found okay, proceed to step 8. Otherwise, make necessary changes in the former till the coil shape is correct. Make the required number of coils. Shape the coils by folding the ends of the straight parts of the coils. Recap.
In this video, we have discussed how to dismantle the motor, record winding data, prepare and provide the slot insulation, and prepare coil winding and forming.